Hello and welcome to my YouTube channel Physics for All. I'm Dr. Abbas and today we will discuss electric field due to a point charge. In our previous video, we just introduced the concept of electric field. So today we will extend it further by assuming a charge Q and we will find its electric field. So for this purpose, we will assume a test charge Q naught net is positive in nature and we will place it at some distance r from that charge Q and we will find the expression for electric field. For that purpose, we will use the electrostatic force acting on this test charge Q naught due to this charge by using Coulomb's law. In our previous lecture, we defined the electrostatic force by Coulomb's law that is equal to F times F is equal to K Q1 Q2 over R square. Here Q1 is the charge. Here we assume it's as Q and Q naught is equal to Q2. So this force we defined there that this electrostatic force is the product of the magnitude of the charges and inverse inverse to the square of the distance between them, that is r. Okay, and this k is constant of proportionality. Okay, so so the first thing about this uh, force is, and here we defined k is equal to 1 over 4 pi epsilon naught, it's constant. So if we want to find the direction of this force F, so it will depend upon the charge. If the charge is positive, so it will repel this charge, test charge Q naught, so the direction will be away from the charge. But if this charge is negative, now it will attract this test charge Q naught, so the direction will be towards the point charge. Okay, if we know know this knowledge of force, electrostatic force, we can find the electric field, which is defined as E is equal to F over Q naught. This Q naught is test charge that we placed at some distance R. So here simply in this relation, we will put the value of F we defined previously, which is equal to 1 over 4 pi epsilon naught Q time Q naught over R square into R unit vector. So here we can see there is Q naught and this Q naught are the same, so they will be cancelled. So we will find that the amount of electric field, which is also a vector quantity, that will be equal to 1 over 4 pi epsilon naught Q over R square. This Q is the magnitude of that charge, white charge. So the next, so this expression will give us the electric field that a static charge Q naught sets in its surrounding. Okay, if we want to find the direction of this electric field as it's a vector quantity, so its magnitude we can find here for this magnitude. And if we want to find the direction, so again, it will depend even our test charge is positive or negative. For example, we have our positive test charge here Q naught, and if here Q is positive, then the direction of electric field will be away, as here we can see. But if the test charge is negative, then these lines will be inward. Here we can see for positive charge, these are outwards. So basically the direction of electric field is same as the direction of electrostatic force F for both cases of positive charge and negative charge. Okay, now we have found this the amount of electric field from this equation 1 for a point charge, and we can apply it for many charges. For example, we have this sheet where we have placed n positive charges. So if we want to find the electric field, we will use the same method as we discussed in our previous lecture for find the electrostatic force for many charges. So in this case, we will place a test charge Q naught at some distance r from this sheet, and we will find, in first step, we will find the force acting on this charge Q naught due to each charge separately. and then we will find the electric field for each point charge, and then we will sum this electric field. So let's start it. So the net charge acting on charge this q naught is f naught will be the sum of force acting on test charge q naught due to charge q1 plus the force acting on test charge q naught due to charge q2 plus the force acting on test charge q naught due to q3 up to the force acting on this test charge due to n charge. Okay. So now once we to calculate these force, we will apply the electrostatic force using Coulomb's law, and for to find this electric field, we will put this uh, all these forces, and we will divide with this charge q naught. So total force that we called it f naught will be equal to f naught 1 over q naught plus f naught 2 over q2 plus f naught 3 over q naught, and so on up to f naught n over q naught. So now we this f over q naught is equal to e. So for this purpose, f naught 1 over q naught is E1, f naught 2 over q naught is E2, and so on. So we will obtain E1, E2 plus E3 plus E4 up to En. So we will have this net electric field. So here actually the principle of superposition holds for electric field, as this principle holds for electrostatic force as well. Okay. So now we solve an example. In this example, there are three particles with charge Q1 plus 2Q, Q2 minus 2Q, and Q3 is minus 4Q. And each is at a distance d from the origin. So we want to find the net electric field which is produced at the origin. Okay, here we have this drawing, the figure indicating Q1, which is a distance d from the origin with an angle 30 degree. Q2 is also a distance d with the angle with x-axis 30 degree, and Q3 is also a distance d from and its angle is also 30 degree. Okay, now what we will do, we will put a test charge q naught at the origin. So now actually if we see, if we analyze q1 and this test charge q naught, both are positive. So this charge q1 will repel this test charge. So its direction will be along the direction of this line joining the origin with q2. Similarly, if we see this q2, it's negative and it will attract the test charge q naught, as here you can see. So the direction of E2 and the direction of E1 will be same. Okay, the third point is our Q3. Okay, this Q3 is negative. It will attract this test charge. So the direction of electric field E3 will be along this direction. So if you see here, you can see E1 and E2 are actually in the same direction. So they will be simply summed, and E3 is in opposite direction. So if we saw this sum of E1 plus E2 and you compare it with E3, we can see their x-axis component of these vectors is in the same direction, but the y component are in opposite direction. So y components will cancel each other, and we will have only this 2 times x component. So let's find it. So in our given data, we have Q1 plus 2Q, Q2 is minus Q2, and Q3 is minus 4Q. So first of all, we will find E1 by using the relation from electric field due to point charge that indicates that E1 will be 1 over 4 pi epsilon naught Q over R square. So this Q, the magnitude of this Q1 is 2Q, and R square will be replaced with the distance D, so it will become D square. Similarly for E2, we have 1 over 4 pi epsilon naught Q over R square, and here Q is minus 2, but we will put mod, so it will become plus 2Q over D square. So E1 and E2 basically are the same. So to find this E3, we will use the same relation 1 over 4 pi epsilon naught q over r square. So in this case, q3 is minus 4q. So minus will be cancelled due to mod, and the distance r is replaced with d. So we will have 1 over 4 pi epsilon naught 4q over d square. So in first step, here you can see E1 and E2 are in the same direction. So we will simply add them and we will find the answer 1 over 4 pi epsilon naught 4q over d square. Okay, so as I said before, here you can see that the x component of this vector E3 and E1 plus E2 are in the same direction along x-axis, but y vector in this case is positive and in this case negative. So y component will be cancelled, but our x component will be doubled. Okay, so if I talk, I want to calculate total E at the origin, that will be 2 times of E3x. E3 is this and E3x is its component along x-axis. So in other words, it will be 2 times E3, the magnitude of E3 times along x-axis. We always model with cos theta, so cos 30 degree. So cos 30 is 0.866. You will put this value here. The rest will remain same. 2 times E3x. E3, the value of E3 is 1 over 4 pi epsilon naught 4q over d square. We have placed this value here. So when you will simplify, you will obtain this answer 6.93 over 4 pi epsilon naught q over d square. So once you know these values of q and d, you can find the exact answer. So thank you very much, dear students. If you have any question, please let me know in the comment section. See you in the next video, where we will discuss the electric field due to a dive.